Welcome to Unit 4, Module 6 of Marketing Analytics. In this lecture, we will explore logistic regression analysis, one of the most widely used supervised machine learning algorithms for classification problems. Unlike linear regression, which predicts continuous numerical values, logistic regression predicts the ability that an observation belongs to a specific category. It is widely applied in marketing analytics for customer purchase prediction, customer churn analysis, fraud detection, and customer segmentation. Understanding logistic regression enables organizations to make accurate, data-driven decisions based on historical customer information. Logistic regression plays a significant role in helping organizations predict customer behavior and business outcomes. By analyzing historical customer data, businesses can estimate the likelihood of future events such as customer purchases, customer churn, loan repayment, fraud detection, email spam identification, and market campaign responses. The model is easy to interpret, computationally efficient, and provides reliable probability-based predictions. Because of its simplicity and accuracy, logistic regression has become one of the most popular machine learning techniques used in marketing analytics, banking, healthcare, finance, and customer relationship management. Although both linear regression and logistic regression belong to the regression family, they solve different types of business problems. Linear regression predicts continuous numerical values such as monthly sales revenue or product demand using a straight-line relationship. Logistic regression, on the other hand, predicts categorical outcomes estimating probabilities between 0 and 1 using the Sigmoid function. For example, linear regression predicts sales figures, whereas logistic regression predicts whether a customer is likely to purchase a product or not. Understanding this distinction helps organizations choose the appropriate analytical technique. Logistic regression is primarily designed for binary classification problems, where each observation belongs to one of two possible categories. Examples include buy or not buy, yes or no, fraud or genuine, churn or retain, and spam or not spam. Binary classification simplifies decision-making by customers or transactions into clearly defined groups. Organizations use these predictions to personalize marketing campaigns, prevent customer churn, detect fraudulent activities, and automate decision-making processes. Binary classification forms the foundation of many real-world machine learning applications across different industries. The sigmoid function is the mathematical foundation of logistic regression. It transforms any numerical value into a probability between 0 and 1, making it suitable for classification tasks. The function follows an S-shaped curve, where very small values approach 0 and very large values approach 1. The probability generated by the sigmoid function helps determine the most likely class for each observation. Because of this transformation, logistic regression can estimate the likelihood of customer purchases, churn, fraud, and many other business events with high accuracy. Logistic regression follows a structured analytical workflow to generate reliable predictions. The process begins by collecting customer data and preparing it through cleaning and pre-processing. Important features are then selected to improve model performance. The logistic regression model is trained using historical data, which it predicts probability values for new observations. Based on these probabilities, customers are classified into appropriate categories such as purchase or non-purchase. Finally, the model is evaluated to measure prediction accuracy and ensure reliable business decision-making. Logistic regression offers several advantages, including simple implementation, fast model training, excellent performance for binary classification, probability-based predictions, and highly interpretable results. However, it also has limitations. The model assumes a linear relationship between the independent variables and the log odds of the outcome. It may perform poorly with highly complex or nonlinear datasets and can be sensitive to outliers. Understanding both the strengths and limitations of logistic regression enables organizations to select the most appropriate machine learning technique for different business problems. Banks widely use logistic regression to predict whether loan applicants are likely to repay their loans. Customer information such as income, age, credit score, employment status, and existing loans is used as input variables. The model estimates the probability of successful loan repayment and classifies applications approved or rejected. This predictive approach enables banks to make faster lending decisions, reduce financial risk, improve credit assessment, and enhance overall operational efficiency. Logistic regression has therefore become an essential tool in modern banking and financial services. Organizations achieve better logistic regression performance by following several best practices. High-quality and reliable data should always be collected before model development. Relevant features must be selected carefully, while unnecessary variables and outliers should be removed. Balancing the dataset prevents biased predictions, and regular model validation ensures consistent performance. Businesses should continuously monitor prediction accuracy and update models whenever customer behavior or market conditions change. Following these best practices results in more accurate predictions and better data-driven business decisions. Congratulations on completing Module 6 of Unit 4. In this lecture, we learned the fundamentals of logistic regression analysis, its importance in classification problems, the differences between linear and logistic regression, binary classification, the sigmoid function, and the complete logistic regression workflow. We also discussed the model's advantages, limitations, a real-world bank loan approval case study, and best practices for implementation. In the next module, we will study logistic regression as a classification technique, where we will explore confusion matrices, classification metrics, model evaluation, and practical application in marketing analytics and business decision-making.